Good day, my beautiful, wonderful, and fellow scientists. We are back again at tackling maths and science with your favorite sensei, me, Sensei Mohao. On today's lesson, we will be dealing with electrostatics. If you're new to our family, press that subscribe button, like the page, and welcome to the family. If you're new to the family, like the page, subscribe, and share the page. Tell your friends to tell their friends to tell their friends that, hey friend, Sensei is back with another fresh lesson. Hope you will enjoy this wonderful lesson because I will enjoy the lesson helping you. So now let's focus on the first thing. Formula sheet. These are the formulas that we are gonna use. I know grade 12s have a formula of finding the force using the charge and the distance. Yeah, we will get to that later on. So for now, we're gonna be focusing on this grade 10s. So now, this is the formula we're gonna use when, let's say for example, there are two charges or two spheres or two balls. They are in contact, then after that they separate. Since you know, let's say the one is positively charged, the other is negatively charged, they will attract because of good. Unlike charges, they attract. Then after that, electrons will be divided evenly amongst them or between them. Then they'll have the same charge and separate. So they will, after separation, they will have an equal charge. Note that. So this is the formula we're gonna use when we want to find the charge. This can be the number of electrons or the number of protons and so forth, the number of anything. And this is the QE, which is the electron mass, which is 1,6 times 10 to the 19. You can see I wrote both, the positive one and negative one. So this one we're gonna use when we are dealing with a negatively charged sphere, and this one the positively charged sphere. And this is how we find the number of electrons. And this one is when we're dealing with electrons transferred, let's say from sphere 1 to sphere 2. We're gonna use this formula, this equation. So now let's dig in. You can pause the video and try to do it on your own, just to practice, so that you can see whether you understand this better or you need to keep on practicing it more and more, because you know practice makes perfect. So now let's now start tackling the questions. It says two small identical balls or spheres A and B are suspended on a long silk thread as shown in the sketch below. Sphere A is initially neutral, note that, and the initial charge of B is unknown, of sphere B is unknown. So now, the first step, we know that A is neutral, B we don't know, it's unknown. So now, yeah, you can see as shown in this diagram. You can take a look at my beautiful $1 billion sketch masterpiece. Hey, so question or information says sphere A is wrapped with a cotton cloth and gains 5 times 10 to the 12 electrons. So now, what do we know? It gives us a hint, good, of if sphere A is neutral and they take a cotton cloth and they rub it and it gains electrons, which means that the cotton cloth was good, negatively charged, which will make sphere A negatively charged. Wonderful. So now let's go to the first question. It says, find the charge on sphere A. So now, sphere A, the charge we're gonna use, since we have the number of electrons, we're gonna use this formula here. So it says n times QE, it's the number of electrons, which is 5 times 10 to the positive 12 multiplied by, since it's a negatively charged, we now know that it's negatively charged and ball or sphere, we're gonna use the negative 1 here. If you want to indicate that it is negatively charged, you might get penalized or lose a mark, 1 mark. So remember always to put in that. If you don't put in it, or rather you use the positive 1, then at the end you just write down that sphere A is negatively charged. It's still applicable, it's still viable, it's correct. So now it's 5 times 10 to the 12 so our answer is negative to the opposite negative 7 coulombs. And this is how we find the number of charge using the number of electrons. So now let's now dig into the second question. It says sphere A is now brought in contact with sphere B. The two charges then separate, but now both of them carry a charge of 3.6 NC. NC stands for nanocoulombs. Find the initial charge of sphere B. So how do we tackle this one? So now says we have the Q nu, which is the new charge on both electrons. Nanocoulomb, this nano, it's 10 to the negative 9. So we know it's 3.6 times 10 to the negative 9 coulombs, which is the new charge on each sphere. So now, do we have the charge on sphere A? Yes, it's this one. It's negative 8 times 10 to the negative 7 coulombs, and we don't know this one. We are still looking for it. So now let's start tackling it. So now Q nu equals to charge on QA plus sphere B over 2, because they will evenly share the number of electrons. So it's negative 8 times 10 to the negative 7 plus, put this inside the brackets because of this negative, plus QB all over 2, and Q nu it's 3.6 times 10 to the negative 9. So now, since we are looking for this thing, first step, we must cross multiply. So it will be 3.6 times 10 to the negative 9 times 2, and here we'll have negative 8 times 10 to the negative 7 plus QB. So we have 3.6 times 10 to the negative 9 multiplied by 2. What did I do? 3.6 times 10 to the negative 9 multiplied by 2. It's 7.2 times 10 to the negative 9 equals to negative 8 times 10 to the negative 7 plus QB. So we solve for QB. It's like solving for X. We take this to the other side. It will become a positive, and we have QB is equals to this plus this. It will be times, put in bracket, 10 to the negative 7, and our final answer will be 8.07 rounded off to 2 decimals times 10 to the negative 7. So this is the new sphere on QB. So now let's do the next question. So now let's tackle the next question. It says, state the principle of conservation of charge. What is the principle of conservation of charge? It states that the net charge in an isolated system remains preserved or is constant during a chemical process. So yeah, let me just write it down. So now question 4 says the number of electrons transferred. You must find the number of electrons transferred from sphere A to sphere B. So which equation are we gonna use? We're gonna use this one. So now it's N equals to delta Q. Delta Q, which it's the new minus the old. So we can even do on both spheres. Okay, this one, this side we're gonna do a sphere A, and this one on sphere B. So on sphere A, the new charge is 3 times 6 times 10 to the negative 9 minus or subtract the old charge, which is negative 8 times 10 to the negative 7 over, since A is negatively charged, it's negative 1,6 times 10 to the negative 19. And here we're gonna do the one for B. 3.6 times 10 to the negative 9 minus, we found 8.08 times 10 to the negative 7 over, since this one is positively charged, it's 1.6 times 10 to the negative 19. So let's use our calculator. So we did this one on the calculator. Our final answer is negative 5.0. Let's just run it off to a whole number. Since it's gonna be 0.2, let's just round it to a whole number. It will be electrons. So now doing this one, we're gonna use comma 0.7, and here my calculator got smacked. So unfortunately, some of the things, because of this white lining, I can't see most things, so please bear with me, but yeah, you understand. So it will be the same number. So you may wonder why here it's negative. It's because of here, that's why. So but the number is just the same, positive 12 electrons. Then you can see it's the same, because here it will round off, here it will be 1, and when we do it in the whole number, it's just gonna be 5. So it's 5 times 10 to the positive 12 electrons. So now let's go to our final and last question. It says, explain according to polarization why the two spheres separate after contact. So now, as I explained before, first thing first, let me just repeat everything again. So we initially knew that sphere A is neutral, no charge. The number of protons and electrons were the same, so it was just neutral. So now they took a cotton cloth and they rubbed the sphere with it, and it gained 5 times 10 to the positive 12 electrons, which means it became negatively charged. So now sphere A, it's negatively charged, and we don't know whether sphere B is positively charged or not, but according to the answers that we found, you can see that it is sphere B, it's positively charged. So now sphere B, it's not positively charged. So between the two, which one is the most negatively charged and the one that is less negatively charged? So this one here, it's more negatively charged. So now, as they are in contact, the electrons are transferred from this one, the most negatively charged. Electrons are transferred from the more negatively charged sphere or ball to the less negatively charged. So now, as the electrons are transferred, then now up until both of them, sphere A and sphere B, have the same they will have now equal charges, because they will have now a balance between electrons. This one will have this number of electrons, which is the same as the number of electrons on A will be the same as the number of electrons on B. So now their charge will be the same. They'll have the same charge. So now they'll have the same charge. Let's say they'll become both positively charged, and we know that if spheres are both positively charged, what will happen? They will repel, because they're unlike charges. You get it? So it's just like that, easy and simple. So now I really had a great time with you in the lesson, and again, if you want me to be your personal tutor, kindly contact me, WhatsApp me or call me, send me an SMS. It's at 081-537-9527. And please, I have a page, Patreon page. It's Maths and Science Tutorials. It's under Musa. And also Instagram account is lamplight_tutors. So follow us there, and cheers. Enjoy the rest of your day. Bye bye.